Welcome to a discussion this morning with Markus MÜller of Reicofil, and we're looking forward to hearing some thoughts from a key person in a key company in this industry that is a major supplier of the meltblown and some of the other non-woven lines. Markus, I'd like to have you introduce yourself, if you might, here. Tell us a little bit about your background, if you would.
Yes, thanks for hosting us. It's a pleasure to have this interview and answer your questions about this really interesting matter, which is moving us all, unfortunately with a sad background, but of course very challenging for the industry. Yes, Markus Müller. I'm working for Reifenhäuser Group since February 1st, 1987, so more than 33 years now of background. I have had different positions. Actually, my background is an engineer for automation. That's what I started with. I did the PLC programming for all the nice Reifenhäuser machines and did installations and commissionings around the world. Then changed into project management after 8 years. Project managers are fairly unique in the industry, so that's one of the key features of Reicofil, that you have a dedicated project manager who's handling the technical portion of each and every contract, from the preparation of the contract until the end of the warranty period. So he's taking care that the line fits in your building, or that you get a building that will fit to the machine, taking care of architects, erectors, constructors, drawings, each and everything. And I did this for about 6 years, which was a very nice job, but then changed into sales. And since July 1st, 2015, I'm the sales director of Reicofil and the member of the board.
And this is an international company. I see that you're putting in lines all over the world, are you not?
That's correct. We are working basically in each and every country in the world, and especially now with this pandemic, we are really looking into remote countries and are serving the people there with machinery.
Yeah, we put together a few of these of your contracts here, and I think just shown that that these contracts are going in, with the Barry, and they're going in with other countries in Europe and Turkey and China and every place. So you really do have a pretty global spread, do you not?
That's correct. And you mentioned Barry. Barry, of course, is our biggest customer, and they are investing heavily around the globe. They have a footprint which is really in all major regions, starting in Asia, over Europe, into the Americas, talking US and also South America. But this is only Barry, and you only see the contracts that are publicly mentioned. Of course, we did have a lot of contracts which nobody knows about it. I can tell you that in the past 4 months, we have sold more than 40 meltblown lines of different configurations and different widths. And this is, as I said, all around the world, and it actually goes with the spread of the virus. So it started in Far East, going to Southeast Asia, then into Europe, and finally into the Americas, into mainly USA, Canada, and of course also to South American countries.
And I think you mentioned, having been involved in the automation, but I think that these are very complex machines, and we have you quoted here, for instance, in one article where you're pointing out that the fibers are a diameter of or less in size, and so building a meltblown line is not an easy task. And I think there are a lot of Chinese manufacturers
exactly
found out that it's not something that can be done and still meet the efficiency requirements. So you might want to comment someone what the challenge is to build one of these plants?
Yeah, it's indeed a challenge to have a line being able to produce fibers where each and every fiber is smaller than 1 micron. 1 micron, a thousandth of a millimeter, and we're talking less than that. And you can imagine that this requires extreme precise machining, extreme precise control of the process. And process starts from the dosing, its temperature control of the extruder, its mixing capability of the extruder. It is equal distribution in a coat hanger die. It is equal heating and or cooling of the die. It is perfect quenching of the meltblown ambient air, and of course a perfect suction. All this requires high precision machinery, high quality engineering, and this is what Reicofil stands for. You mentioned the Chinese. Yes, there is, when we look at our more than 40 orders, this is peanuts to what some Chinese guys have made. They have sold more than 100 meltblown lines, all into China. Now they're desperately asking for help because they cannot even achieve the N95, which is the lowest quality for a face mask filter. It's simple due to the fact that these lines are very cheap, and very cheap at the end of the day costs you more money because you're not able to produce. So unfortunately, some lines in Europe or some customers in Europe were blinded by this and have bought this machinery, and now they sit there with a machine which is not able to produce. The other problem is that there is an unbelievable amount of face mask converting machines all over the world and also in Europe. And that's what people invested in because it's obviously much cheaper than a meltblown line. And at the end of the day, they all have nice, more or less nice machinery standing there, but no material to feed it. And that is the issue, and is still the issue.
Mm-hmm.
So looking on China, yes, they invest heavily, but the trend globally is to go away from China. And this makes sense because you cannot rely on the quality that you are getting from there. And I mean, you all read the stories. We also in Germany had the issue with government ordering face masks, a couple of millions, very proud. Actually, it's peanuts when you look what is coming from a machine, but they were very proud to order millions of face masks and they never arrived. Or in other case, they arrived, but they were crap because they didn't work. They did not fulfill the function of, attacking the virus.
Right.
It's a big difference, actually.
Yeah, that's
so. What we're talking about is localizing, and we think that's the right approach. You have to rely on yourself. You have to rely on equipment that you handle yourself. Then you know what quality you have. You cannot trust in this serious, life-threatening question or life-threatening matter. You cannot rely on somebody else. You have to do it by yourself.
Yeah, I think that even though you get a one of the largest chemical companies in the world, Sinopec, who put in 16 tons per hour of 16 tons per day of capability in a relatively short time. It's one thing to be able to do that in a short order. It's another thing, as you're saying, to get the precision that that you need. Yeah. In that
Sinopec actually is one of the companies who is asking for help now. We have the sister company of Reicofil, which is Enka, and Enka produces, of course, for us, they produce the meltblown die tips, which is one of the key precision part of a meltblown system, but they also produce the complete coat hanger with the meltblown cassette system, which they call the smart meltblown system. Now, Sinopec is asking them for delivery of, dozens of complete meltblown coat hangers because they learned the hard way that they have the machinery. Yes, they installed it in record time, Yes, but unfortunately, they cannot produce the required quality.
Well, that's interesting. In that regard, we've been working with the Wall Street Journal. Keith Bradsher is the Shanghai chief of the Wall Street Journal, and he spent months analyzing, the Sinopec and the masks and so forth there. And his article came out about 10 days ago. I think it was in the Sunday Wall Street Journal. It was over a whole page with lots of pictures and months of research. I'll be interested. I'll see that you get a link to that article, and we'd be interested in some of your comments. Going forward on that relative to the Chinese market. Before we go too much further, though, because you described the whole series, tell us if we're looking at a complete line here on the screen right now. This diagram that we have in front of us here, when you were describing your line, is this what we're talking about in terms of an overview?
Actually, I don't see what you're talking about. Maybe you did not share the screen.
Oh, okay.
Hold on, maybe no, I got it. No, that's right. I got it. I see it now. Okay.
Right.
What you see in this picture actually is a composite line. What you see here is an SMMS line. This is not a line that is suitable for making face mask material. This line, however, has come now again in the focus because worldwide we are lacking SMS material, especially for protective clothes. And I would like to comment on that later.
Oh, okay.
If you go on our website under the section meltblown lines, you see a typical meltblown line.
Oh, okay.
Yeah, go scroll down. Yeah, there you go. That's it. That's the meltblown line.
Okay.
What is missing here? It's actually where the face mask is introduced. We need the electrostatic charging unit, and of course, we need a winder.
Okay.
But the core technology, the key components are shown in this.
And the time frame is, I think we got down here, the 3.5 months for a meltblown line. Yeah. But on the other hand, for the composite lines, you're talking 10 or 11 months for a much more complex operation.
Yeah, but this I have to correct, and you also, I ask you not to mention this anymore. This figures that are mentioned here is from an article, I think back in March or so. Yeah, it says March 18. This situation obviously has changed completely. I mean, completely. We are looking now on delivery times of up to 14 to 16 months for meltblown lines and more than 20 months for composite lines. Okay. Because we're completely sold out. We are, at the moment, we are shipping every week a meltblown line, and we're shipping every month a big composite line. And the issue is not, it's also an issue, but not the biggest issue is not to build it here, to erect the parts. It's also to have people installing it and commissioning it around the world, especially with all the restrictions that are in place due to Corona.
So you're able to produce one plant per month. Is that what I'm hearing you saying? One meltblown line per month?
No. Meltblown line one a week. Every week.
Oh, okay. Yeah. So, so basically, if we needed 277 of these meltblown lines, it could be done in less than 5 years. Yeah,
around 5 years, whatever. Yeah.
Well, yeah, right. So that's the kind of time frame we're talking about here.
But there is different size of meltblown lines. There's different size of masks, so you have to differentiate. If you look on the small line, a 1.6 meter single beam line, this gives you around 2 million face masks per day. 2 2 million per day, or considering 7,500 hours per year, around 650 million. Yeah.
Oh, okay.
And now you can run your math again and you come to possibly different figures. But keep in mind, there is also 3.2 meter machines, which obviously delivers exactly double the capacity. And we are selling double beam meltblown lines 3.2 meter, which quadruples this capacity. So you got to be careful when talking about lines and capacities and to fulfill the need. Reicofil can definitely work and help to fulfill the need for face masks globally.
What about the alternative materials, the variations on the spun bonded line? I think the University of North Carolina, for instance, is touting a spun bond variation that they're producing there. There's various different. I think another development too is a somewhat less efficient mask, an N80 mask that would be using some of the SMS materials that are used in the protective equipment, the gowns and things. Would you like to comment on all that?
I can comment. Number one is, again, here you have to be careful because a face mask consists at least of 3 layers. Consists of the inner layer, which is touching your face, which is a spun bond material. Then the middle layer, which is the meltblown that we talked about so far, which is the decisive layer for the filtration. And this may actually be installed in 2 layers in order to increase the filtration capacity, but still keep up the breathability or air permeability of this material. And then we have the outer layer, which is again a spun bond, but could also be a carded product, especially when it comes to the formed masks for FFP2 or FFP3 mask, where the mask has a certain form or shape. So you have to be careful when you hear somebody is doing spun bond for face mask. Yes, of course, spun bond is needed for face mask. I definitely warn about everything that says we can do the filter material from spun bond. It simply will not work. The spun bond fiber, even if it comes from a Reicofil 5, even if it is the latest and greatest and the super material and everything, is still 10 times thicker than the meltblown fiber. Ultimately, the pore size is at least 10 times bigger than the meltblown fibers. Now, an untreated meltblown fiber having less than 1 micron diameter still cannot catch the virus. That is why it is electrically charged. And only with this electric charge, you can catch the virus. Now, believe it or not, there is a lot of mistakes happening after this material is produced. Some people rewind and slit the material using winders and slitter rewinders having ionization, which is nothing else but electrostatic charging in the system to increase the winding quality. If this electrostatic charging is in the same polarity as ours, fine. But most of the time it's exactly the opposite. Now what happens? You discharge the meltblown material with the effect that you lose all the capability of the filter. We even see face mask converting machines coming from China, cheap stuff, that try to overcome their deficiencies by installing this electrostatic chargers in order to keep these 3 or 4 layers together when it goes into the converting machine. There's so much problems and sorry the word, so much shit happening in this industry at the moment, you cannot believe it.
Yeah, and I think that, with our daily alerts, we're trying to dispel some of this misinformation, and
Yeah.
relative to the efficiency of the filters, we're showing that if both the transmitter and the recipient both wear a meltblown mask, the amount of inhaled viruses by the recipient are a fraction of what they are many times less than they are if you're wearing an inefficient, cloth mask or something.
Yes.
So,
Yes, exactly. And what happened in the industry when COVID-19 started, everyone was making their own mask from fabrics, which have a super coarse fiber and super high porosity. This is no protection at all. No protection at all. It only reduces a little bit the aerosols that you exhaust when you cough or when you sneeze. But that's it. That's no protection. And people called it protective mask. This was ridiculous.
Right. And then you talk about, go ahead.
Yeah, go ahead.
No, I was just going to say that, I've been thinking about this coughing and sneezing too. What happens when you cough and sneeze into a cloth mask? You get material that resides on the internal side of the mask only temporarily. If you're breathing through it and exhaling and inhaling, particles are going to start evaporating from that material.
Exactly.
And so,
Exactly.
and if you're wearing an inefficient mask, you
Exactly.
just, eventually you're going to, make sure that all the particles, which could be several million particles in one sneeze, all of them are eventually going to evaporate and go out as small aerosols. So I think in our daily alerts, we had 240 scientists basically tell WHO in a letter last week that it's airborne small airborne viruses that are the problem, and they even refuted the WHO claim, which is, well, we don't know yet. We have no real evidence that that much of it is the airborne virus. And the scientists were saying, you don't have any evidence that it's through touch or anything else. Nobody really has all that evidence, but you can observe, and obviously when all the people on the 400 people in the Diamond Princess get the virus, even though they've been kept away from each other, and all you've got is an HVAC system that links them. It's pretty clear.
Exactly. Yeah.
Yeah. So we're doing this. Go ahead.
It's a big problem. It's a big problem, and unfortunately, still it's not taken really serious. I mean, all over the world, except for Asia, because Asia is used to wear masks. They are really very strict on that. Okay, you cannot believe the figures that China publishes, but you can trust the figures that is coming from countries like Singapore, Malaysia. So it's fairly low. Looking on other countries, and with all due respect, especially looking on America, it's a nightmare. It's a nightmare, and it's only because people are not wearing masks, and that's the issue.
Yeah, and I think it's more than that too. It's and we have many interviews with the people that are selling the air pollution masks, and as you know, they're down. The air pollutants are down in that same size range as the virus particles. So unless you wear an efficient mask in Asia, you're not going to keep out the air pollutants. So it's not only that they're wearing a mask, but many of them are wearing the efficient masks, and I think that that's a big difference that needs to be understood.
Yeah.
I'd like to have you talk. You said you were going to talk a little bit about your composite lines. For the protective, the gowns and some of these other things. Tell us a little bit about what you're doing there.
What we see is, if we look back a couple of months, it started all in March, the high demand for meltblown material. Ultimately, we got requests from our existing customers to convert their SMS line, or to enable their SMS line to produce material for face mask. And obviously they learned the hard way that it's not possible to do it as an SMS composite to produce the materials in one go. It's impossible. You have to run individual rolls with individual layers that are then put together in the conversion machine for the mask. So what happened is, number one, our customers with huge lines, typically producing for baby diapers and for female hygiene articles, and of course the couple of them who are producing medical products, they switched off their spun bond beams in the SMS lines only to produce meltblown, to fulfill the market need of meltblown. Of course, I would have done the same. It was and is a very nice business. Unfortunately, the SMS material was gone. Now, the next step is that due to the high demand in the hospitals and in the health sector of protective clothes, the demand for SMS medical material exploded, absolutely exploded. On the other hand, these materials typically were coming from China, but nobody wanted to have them from China anymore. They want high quality, the insurance to be perfectly made, and so they start making it by themselves. This increased in Reicofil the demand for SMS composite lines drastically. And as I said, we are selling a line every month, and we are sold out now for the next 2 years. So it's huge. And if you compare the capacity of one meltblown line with the capacity of a SMS line, it's very big difference. Very, very big difference.
And to explain for our listeners here too that it's the advantage of mixing the spun bond material with the meltblown that you get some of the efficiency of the finer meltblown particles with the strength and other characteristics of the spun bond. Why don't you walk us through why you would have a composite material?
Yeah, exactly. The meltblown gives you the water tightness or the liquid tightness that you need in protective clothes. It gives you the filtration and the protection against stuff like viruses, but mainly it is the protection against liquids. And when you are in the health sector, you have to deal with a lot of liquids, especially when it comes to surgeries. And that's where SMS material are used, and you are right, the spun bond gives you the physical strength and the meltblown gives you the what is called hydrohead, so the water resistance or water repellency of this product.
The other use of certainly of gowns is in, say, pharmaceutical and semiconductor clean rooms, and the fact of the matter is that the human body sheds hundreds of thousands of skin particles every minute, and that you therefore need an efficient gown if you're working, say, in a class 100 pharmaceutical clean room, or and so are some of your composites used for those clean room applications as well?
They are definitely, and they are used depending on the requirements. They are used as SMS products, or when the standard has to be very high, it's actually a laminated product, SMS, with very thin film to make it really tight. And this is also used in the health sector when it comes to the highest protection degree. And what is important to know is that you cannot wear these suits for a long time. You have to throw them away, otherwise you run around as a biological bomb, So you have to throw them away. Unfortunately, this did not happen in the peak times of coronavirus in the hospitals. These gowns are used for several days. And doctors and nurses are asked to put them in the oven to sterilize it and to wash it, and I mean, crazy things going on, crazy things, just because it's not enough. Nothing is enough there.
Yeah, you mentioned the breathability aspect of it, and in our alerts we talk about in South Korea there's a requirement for every high school child to run 1,000 meters. And so they were requiring the children to run the 1,000 meters here this June, and everyone had to wear an N95 mask. And two of the children actually died just in the running of those trials. And now of course they've stopped that, but it brings out the problem of breathability. And I had a couple questions along that line. If you have a mask that has twice the area of the pressure drop goes down by the square of the velocity, so the more media that you can put in a mask, the higher the breathability, is it not?
It depends. At the end of the day, it's a matter of how you run your meltblown, and especially the meltblown has so many parameters in setting. If you see a meltblown line, you have, of course, the temperature of the melt. You have the temperature of the process air. You have the quench air around the meltblown stream. You of course can control with the air knives. You can control the setback and the air gap, and with this you finally control the size of the fiber. You can control the swinging of the fiber. Then you have the so-called DCD. That's the distance from the collector belt to the die. This is something to work with. The Reicofil conveyor belt machine is a tiltable machine, which can be set in an angle under the stream of meltblown. It has also an area which is rounded off. So we have a lot of parameters where we can play and find the right setting where we have optimum absorption and still a very good air permeability. I mean, in simple words, the best protection is a duct tape over your mouth. Then you're fully safe. Unfortunately, you cannot breathe. And so you have to find the right way in between. And I'm sad to hear about these poor little children that died. But for sure, these masks were made from a very poor meltblown material. In addition to this, what we see is in the materials coming from China, in the meltblown, we see a lot of residuals of oil. This oil is coming from the compressor. Each meltblown line uses a fairly big compressor, and the compressed air has to be, of course, absolutely oil-free. And what we see in coming from the Chinese line, they're absolutely not oil-free because they use standard compressors, which is used for industrial air, or I don't know, some cheap crap. And this leads to the fact that you have the oil in the face mask. And I know it by myself. I try many different face masks, and some of the masks you put on your face and you immediately get, kind of a headache, kind of a bad feeling. And then you smell it. It's oil in the meltblown. Huh. And all of this is an issue. When a child has to run a mile or a kilometer with such a mask, forget it. I mean, it's terrible.
Yeah, well, one last question I have then is, this is a complex operation. What kind of support do you have for a customer who buys one of your machines?
Number one, so far we try to erect and at least supervise the erection, and of course fully commission the line at site. So far that worked. With COVID-19 in place, you never know. But we were thinking ahead. We have prepared a center for a remote installation support with data
Did we?
Still can do that.
Yeah, we missed. I think I missed the last sentence. Something happened there. Would you repeat that about your remote center again?
As I said, we try to install and commission the lines that we sold in person. I mean, really by being there. If for whatever reason, and mainly due to COVID-19 regulations, we cannot travel there, but the machine is there, we are able to virtually support the customer and his staff to install the machine by himself. We have done this already twice, very successful.
Can that same remote connection be used to provide remote support over time as during the operation of the machine?
This is standard for every Reicofil line anyway.
So that you're able to monitor machines as they're operating.
Yep. Yes, we have each, of course, not the old ones, but let's say from the last 15 years, I would say each of the lines are connected through a VPN net. The clock taking care of lines that have some issue.
Well, that's certainly very very interesting. Well, Markus, that's been a very educational interview for Ross and I, and we'd like to thank you for taking the time today. And
more than welcome.
I'll send you that Wall Street Journal article, and let's stay in touch on the developments here. And you know, your company certainly is a key company in all this, and so we appreciate the opportunity to interface with you.
Yes, it was a pleasure. Thank you very much. I hope that we can, I would not say educate people, but at least make certain things clearer to many people who have not the full picture of what it's all about, and when it comes to personal safety.
Yeah, and I think this was a good contribution in that regard. And we will send you the link to the recording for you to use however you might, and look forward to working with you in the future.
Very good.
Okay,
thank you very much.
Right, bye now.
Thank you. Take care. Bye.